Welcome to the major content of this course, that is on machining fluids. So we studied the basics of machining, especially single point cutting tool, and we move after the machining fluids to the multi-point cutting tool and conventional finishing process and all those things. The major content of this course is also depends on the machining fluids. So why I am giving you great importance of this one is machining fluids nowadays accord equal importance corresponding to the machining process. That's why this is a big topic nowadays from the point of research is concerned. At the same time, from the humanitarian grounds and all those things, whenever we come across some of the things like emissions of these cutting fluids during the machining operation or finishing operation and all those things. Clearly listen, because many things are chemistry oriented here, biological oriented here, health issues will come. Okay, this is not like whether metal cutting process where you are just doing feed, depth of cut and speed, and you are measuring the cutting forces, temperature and all those things. It is slightly beyond that, where you can measure what is the chemical oxygen demand, biological oxygen demand. These type of words will come into the subject. So be there to learn more things, what we see and how we see this mechanical or the manufacturing aspects from the other perspective, like chemical perspective and environmental perspective and all those things. Okay, welcome to the machining fluids, which is also called as cutting fluids and its additives. I just talk about what are the additives that you will add and all those things, and I will talk the beauty about these additives in this lecture, and I will talk the negative aspects about these additives in the upcoming lectures. The overview of my presentation for this lecture goes like this: why we required the machining fluids or the cutting fluids. Majorly I talk it as a cutting fluids from now onwards. Okay, so introduction to the cutting fluids and its functions. Anyhow, many of you know it, but it's my primary responsibility to remind you what are the functions. Not only what you study in the textbooks, some of the functions are taken from the research point of view also. Okay, those who are interested to take these cutting fluids as one of their prime research work, it is a huge amount of work that one can take in this aspect. Types of cutting fluids, what are the types? Synthetic, semi-synthetic and many things. The cutting fluid properties, what are the properties that you want in a cutting fluid so that you can achieve your goal. So cutting fluid additives, this is the one where you have an elaborative ranging from emulsifiers to rust inhibitors and all those things. And the cutting fluid is ecological aspects will be there. Okay. So till now we have seen the single point machining tool, and now we are moving to the machining fluids. As I just now said, in this course, introduction to machining and machining fluids, why I am reminding you is this course itself says machining fluids. So it is my responsibility to give you some slightly extra knowledge about the machining fluids compared to how a mechanical engineer or a manufacturing engineer look at that perspective. Need of cutting fluid in the machining. So what is the need of the cutting fluid in the machining? Just you see here, the basic problem in machining is heat generation. As we have seen thermal aspects of machining, so during the machining of metals or non-metals or something, considerable heat is generated when the conservation of mechanical energy converts into the heat energy. Okay, severe plastic deformation will take place. You can see this is the primary shear zone. Severe plastic deformation is taking place where the mechanical energy is converting into the heat energy. So there is a three zones where the heat generates. One is the heat in shearing zone, which is a major amount of the heat generated. for which you are using the cutting fluid to extract the heat. Heat in chip tool interface. Heat, we have already seen the heat takes place in the chip tool interface because of two things. One is chip is carrying the plastic deformation zones temperature. At the same time, frictional heat between tool rake surface and the chip bottom side will also causes two things. So these two will be there. And heat in workpiece interface, tool workpiece interface. Tool workpiece interface will have a frictional rubbing action where dominated by abrasion action that also causes interference. At the same time, workpiece also carry 3 to 5%. So if you see in all metalworking, the plastic deformation is involved. I am saying you the plastic deformation is involved, which is, I can even say that it is a severe plastic deformation because it is taking into the severe zone where the material failure takes place. As I was already telling you that metal forming process and metal machining process for failure is not required in the metal deformation processes, but failure is required in the metal cutting operation. Then only the metal shearing takes place. Okay, the energy dissipated in the cutting converted into the heat, which is in turns raises the temperature of machining. How it will raises? Just I might have already shown this video, but since it is an apt video for this cutting fluid application, that's I will just go and show you again. You see how the fireworks will takes place in this one. If you see here what is happening, the machining is taking place at extreme conditions on a hard machine workpiece. So what is happening here is, if you see in this video, what you can clearly see is the lot of heat is generating. Not only heat is generating, the chips are coming like firing bullets. At the same time, if you clearly see, there is a accumulation of hot chips, which is a continuous chip in that location. That is very harmful because your final product is coming in this direction. If your final product is coming in this direction, if a chip is entangled there, it is disturbing my final surface roughness, which is coming as a product, plus it is also giving some heat input because my chip is red hot chip, which giving the heat to the workpiece, which damage the microstructural on the surface of the workpiece. That is two disadvantages. For how to overcome all these things, we will see in the cutting fluid applications. Okay, so further we proceed. You can clearly see the video. Now you can see the lump is coming out where the continuous chip, red hot chip is coming, and you can clearly see in this region the red hot chip is coming, and it is disturbing the machining process. At the end also the same thing is clearly visible. There is continuous red hot chip is there. If these type of chips are presented, this disturbs the surface morphology as well as metallurgy, which we have studied in the last week courses. How to eradicate all these things or how to minimize these things? For that purpose, we will use the cutting fluids, or you can go for another alternative, that is called alternative. What you can go for, it is hard cutting tools, which may increase the cost of the production. So the cheapest way or the economical way how you can go ahead is cutting fluids. Okay, So that's why that is a need of the cutting fluids. Okay, proper methods whenever these type of things are there, how you have to utilize if we have a cutting fluid. Okay, you cannot throw it like a mad person. Okay, you should usefully utilize how to send. If you see here, figure A, this is a good way and this is the poor way. Why? So the heat is generated in this region where chip tool interface is there. At the same time, in the good way also, if it would have been done at certain degrees, recently their studies shows that if you send at 45 degrees, that will be better. That was some of the researchers has conveyed. Okay, so it may be better. Whatever is given is a good. So what you can go ahead is better. So this would be better. I am not saying the best, but it would be better. The poor, why it is poor? Because the cutting fluid is falling ahead of my machining region, which is not required for us. At the same time, if you see in the good, there is a cutting fluid application from the flank surface side also, where the workpiece rubs against the clearing surface, flank surface, or the real relief surface. Okay, here what normally you will send is a lubricant based cutting fluid. You will send in the flank surface. Here in the good one, where you choose on the chip tool interface, where coolant type you will send. Okay, because the temperature extraction should be there from the top side and the abrasion is dominating in the bottom side. That's why you always go for a better lubricant, so that the lubrication will be done as you have seen the tribological lubrication and all those things. In the milling operation, the good one is like in the milling cutting region. I will come to the milling in the upcoming whenever I am going to talk to you about the multi-point cutting tool and all those things. Anyhow, some of you know what is a milling, what is up milling, what is down milling, okay, and all those things. So anyhow, I will teach you, but however, just to show from the cutting fluid point of view, this is a good way to apply the cutting fluid. And if you are throwing on the tool top side where the cooling is already done by the atmospheric air, you are just wasting the cutting fluid. If you see the grinding, normally teeth grinding and all those things, this is a good way. And if you see in the drilling, normally you should send along the flutes, so that will be better rather than cooling the surface of the workpiece at certain different location where it may not be required. It may be required, but the thing is that the heat conductivity to that surface may not be required. That's why this is not a preferable choice. So if you can send through the flutes or in the machining region, what will happen? It will lubricate, it will cool, as well as additional effect in the drilling process is it will try to evacuate the chips. That is the beauty and the third function of the cutting fluid. Okay, in detail functions we will come across in this lecture about the cutting fluid and its requirements and all those things. As just now I was telling, so now we come across about the purpose of the cutting fluids, and it are none other than its functions. So the first and foremost function is normally depend on the manufacturing process that you are choosing. Either it can be lubricant function or coolant function. This has a equal choices or equal importance basically, because if you are going for low speeds, lubricant type is required. If you are going for high speeds, normally the coolant type is required. Okay, so lubricant type, normally it will reduce the friction and wear in the machining region. About the, I am talking about the tool. Okay, if at all I am using the coolant, what will happen? It will cool the machining region. That means that it will try to cool the chip, it will try to cool the tool, and it will try to cool the workpiece also, which is carrying certain amount of heat. So if you are cooling and all those things, if you are doing, what will happen? The another benefit that you are going to achieve is reduce the forces. If you reduce the forces, the energy consumption will be less. That is what Fc into V. Normally it will go down. So your energy requirement or power input will be obviously will go down. Okay. The protect the mechanical surface from the environmental corrosion. What do you mean by this? If at all, what I am talking is about the corrosion, environmental corrosion. Environmental corrosion comes from where your environment contains oxygen, nitrogen, and many chemicals it is or elements it is having. Nowadays, if you see lot of pollution is there, so many elements are there. Okay, many elements are there. Whenever the machining operation is going to takes place, lot of heat is generated. The surface is very hot. In that circumstances, if these environmental aspects come into and elements come into picture, it will have corrosion on the surface. Especially in terms of iron based components, there will be a corrosion. So in order to protect all these things, you try to use the rust inhibitors or corrosion preventers. Okay, if your cutting fluid contains the particular part of this rust inhibitors as a ingredient of the cutting fluid, then you can prevent the environmental corrosion. Flush away chips from the cutting zone. As I said, if you are impinging the cutting fluid with high pressure in single point cutting tool, or as I said in the previous slide in the drilling operation, what will happen normally is, so you will evacuate the chips. Okay. So that is what at times using the cutting fluid may cause the material to become curly, which concentrate the heat closer to the tip. This detrimental because it decreases the tool life. As I just now I have shown you the video, what will happen? It will concentrate, if it is curly, and which is concentrate the heat closer to the tip, because as the video shows that chip is curling there on the rake surface of the tool near the workpiece, okay, which is upbraiding the tool rake surface. At the same time, it is imparting the lot of heat to it. That's why it decreases the tool life. That is most important point, which practically you have seen in the video. Depend on the type of machining operation, coolant, lubricant, and both are used. If your requirement is for lubrication, you have to choose lubricant. If your requirement is coolant, cooling is major or the dominated mechanism in your machining process, then you choose the coolant. If both are required, then choose optimally. That is what it says. Effectiveness of cutting fluid depend on the type of machining operation, which type of, whether you are doing lathe operation, that is turning operation, threading operation, broaching operation, milling operation, tool and workpiece materials, and cutting speed. Cutting speed normally determines the heat generation. Tool and workpiece material combination is also a factor. If you are going for stainless steel versus HSS, you cannot do machining for hours and hours, okay, because the hardness ratio is very poor. That's why you have to choose better workpiece material and tool material combinations. So if you see here, there is a picture, that is what this is the cutting fluid. Basically, whenever you purchase from the market, I am talking about this picture. Okay, so normally the cutting fluid is very good lubricant, but it may not very good coolant. That's why always you add with this cutting fluid plus water. So whenever you add water, it will become a milky type of color, that is white color and all those things. Okay, so this is how it will convert from this to this whenever you add H2O to it. Okay, that's, you might know some of the people, but those people who never experienced the workshop practically, for those purpose I am just telling you the basic. So these factors, all factors, if you see the cooling, lubrication, evacuation of chip, and decreasing the temperature, and curling, flushing away of the chips, these are all directly or indirectly controls the tool life, and it will improve the process. That is nothing but it is makes your the process efficient in terms of machining is concerned. That's why always you go for the cutting fluids in the machining process if it is required. Now you can see the types of cutting fluids used in a machining. This slide I am going to elaborately touch in the next class. Since I am going to talk about some of the additives, let me slightly say that on y-axis you have a cooling properties, on x-axis you have a lubricating property. Just now I told, if you have a cutting fluid, you always add water to it. Okay, whenever you are adding water, you are improving the cooling properties. Why? The proof here from the literature is that water is a better cooling property liquid, and mineral oil or the lubricant, whatever you are getting from the market, is a better lubricant. So if at all you want better, so you have to make the emulsions. Okay, so what you do is, mineral oil you take and you add H2O to it, you are going to get the emulsions. Will have optimum cooling properties as well as optimum lubricating properties. This will have cooling properties plus lubricating properties, both. If you choose mineral oil, it will have a lubricating property. If you choose water, it will have a cooling property. That's why, to optimize both the things, if I required in my machining operation both cooling and lubrication, then I am going to use emulsions. Okay, cooling plus lubrication. So emulsions contains water. If emulsions contains water, whenever the high temperature machining is taking place, the water will react with the iron based workpieces and causes rust. For that purpose, you always add some additives. You can see here, always there is additives. Mineral oil with additives, emulsions with additives, water with additives, and others. What are these additives? That was the major thing that we are going to see here. Some of the additives are biocides, helps in preventing the microorganisms. Rust inhibitors, so rusting it helps, as we have seen in the previous slide. Anti-wear additives, it will help better lubrication. Extreme pressure additives, at extremely high loads, your additives will provide the lubricity for proper lubrication and all those things. The pressures are much high in terms of broaching operation and other things. At that pressures, how my additives are going to help for better lubrication and all those things, that we will come and see. Okay, so regarding this, as I said, we will see again this slide in the upcoming classes, because this is the graph that have great importance from the point of lubrication as well as cooling. The cutting fluid types, normally one is the oil types, wherever you see petroleum. Nowadays, if you see the companies like Servo, they will supply Servo Cutters, is one of the oils. Okay, these are all mineral oils. Okay, so animal, vegetable, compound, lot of oils are there. Then emulsions. Anyhow, just I will show you the emulsions. Emulsions are nothing but the mixture of oil and water along with additives that you have seen in the previous slide. Good for operations where the temperature rise is significant, because it will also cool. Semi-synthetic, these are the chemical emulsions basically, which contains a mineral oil diluted in water with additives and reduce the particle size. Okay, these are the chemical emulsions. The above ones are mineral oil based, water based emulsion. These are chemical based, synthetic chemicals with additives. Basically, here emulsions are used in the semi-synthetic. Here, directly chemicals are used along with additives. Okay, and you can even dilute with the water or without oil also. Okay, so you can do that. So if you see range of cutting fluids, as you have seen in the previous slide, water it is a better cooling fluid. Okay, so soluble oils, normally soluble oils will easily mix with water, that's why it's called soluble oils. Straight oils, normally whose chain is very big, normally if you see the chains like a large chain, small chain, medium chain, these are the chemical compositions like alkanes, alkenes, alkynes. If the chain is goes beyond C30, normally these are main branch is dominating. At the same time, the sister branches or the side branches will be not dominating much. So these type of oils are one of the straight oils. These are mixed oils. You can mix with 2-3 varieties of oils. Chemical additive oil. So as I said, semi-synthetic oils normally are called as a semi-synthetic, where you can add chemical synthesized oils along with the mineral oils, chemical compounds directly. As I said, synthetic oils are completely chemical compounds where you can add water to it to make slightly emulsion, and the solid lubricants. Solid lubricants are normally nanoparticles or microparticles. Okay, nanoparticles where you will use the or microparticles also. You can say microparticles also, plus compressed air. With this, you will send it to the machining region, and you will get the lubricant. Here, basically, the lubricant action is dominated compared to the cooling. So, whatever the air that you are sending, assume that you are sending a cold compressed air, that will be better here. Okay. So, whenever somebody want to take the research work in this area, so solid lubricant you can take along with that cooling fluid, that is cooling gas, or normally the air. Cooled air you can impregnate with the solid nanoparticles, which are better lubricants, and you can send it to this one. So your cooling fluid will extract the heat because it is at a low temperature. At the same time, being a air, it can penetrate into the region. So people, very less work is done in this area. So people who are working in the solid lubricants for machining applications, you can try with low temperature, high pressure air mixing with solid lubricants, and you can send it to the machining region and you can check, and you can even compare with normal air, and solid lubricant particles also you can vary. So you sometimes the problem is, if whenever you are going for nanoparticles, agglomeration is a problem. So you have to optimize the particle size, how much volume of the particles you are sending, that is discharge, how much you are taking. You can play with the volume amount or the discharge, at the same time particle size, at the temperature of the fluid, that is air that you are sending. So you can play air pressure and all those things will play on the volume discharge. So lot of interaction factors and all those things are there. So if somebody is interested, you can get a very good PhD topic out of this one. So please work in this area. Okay. As I was saying, no, this is not only the course for beginners like second year BTechs, it also goods for the first year MTechs and PhD also. So my topic, any BTech student likes it, this topic, you can take it. MTech student, you are free to take. Okay. or you can go to my website and you can write to us, sir, this is what we were looking, any suggestions you want and all those things. We can always help you. See, as we work in this area, so we have slightly better knowledge, so we can help you, and the spreading knowledge is what we are here for. Okay, so the cutting fluid method application, the flow rates are normally, if you see the flood cooling, if you see the flood cooling, what are the method application is, there are many types of techniques, where one of the commonly used technique in India nowadays in the industry, especially small scale industry, is flood cooling. Okay, where the cutting fluid falls 10 liter per minute. Normally it is too high, but whatever the textbooks refers is 400 to 600 ml per minute is the one. So this is slightly high because we have taken from some of the old textbooks, so it may be. At the same time, the basic problem here is a poor visibility. Okay, I can say that this will be like 400. Effectively nowadays people are working in the range of 400 ml to 600 ml per minute. Okay, so on an average you can say it is around 500 ml per minute. This is the average value. Okay, so the basic problem is poor visibility. As you have seen, the cutting fluid is extremely milky type, so it will cover. If the fluid content is very high, what will happen? You cannot see the machining region. Okay, that is the basic problem. At the same time, cutting fluid is very high, so emissions is also very high. So emissions, whenever you see in the next classes, so you will really see what is the basic problems. So second one is the missed one, where you have a better visibility. What I mean to say, better visibility doesn't mean that it is transparent or something. Here you will mix the cutting fluid with gas and you send the atomize, as you have seen in the MQL. It is one of the other names or the synonyms for minimum quantity lubrication, where you send the air plus cutting fluid and you just circulate into the grinding operation or machining operation, any type of machining operation. Okay, so this is most popular one nowadays. Abroad nations are following, so India, hopefully some of the companies are following, where good visibility is there, so people can see what is happening in the machining region and whether the tool wear is taken, or how the progress of tool wear is taking place and all those things. Some things you can see, if not 100%. So the third one is high pressure systems, that is if you want to send the cutting fluid with high pressure, so normally you will go for this one. So here the cutting fluid will consumption will be very high, even compared to the flood cooling. Okay, your flood cooling, I said 400 to 600 ml, here it may even cross 1 liter also. Okay, and the beauty about this one is, if you are sending a liquid jet with high pressure, the prematured chip that is coming from the machining region may break. That's why it will also act as a chip breaker. Okay, that is the one of the advantages of this high pressure jet, liquid jet that you are sending. At the same time, it will also clear the debris, if at all, if there is any formation in the machining region or in the chip tool interface and all those things. Okay, this is the additional benefit that one can do. Through the cutting tool system, it means that you are making commercial tools are available, where you will have a through holes in the tool holder as well as in the tool, through which the cutting fluid passes and directly enters into the machining region. To make sure that here also you may not go into the sticking and sliding regions, but it has a better chance because these holes are directed towards the chip tool interface as well as flank and workpiece interfaces. That's why you can cool the hot area, that is where the machining is taking place. Okay, these are the 4 techniques where flood cooling, mist cooling, that is minimum quantity cutting fluid or minimum quantity lubrication, high pressure systems, that is high pressure cutting fluid application, and through the cutting tool system. As I said, through cutting tool system can normally work with high pressure cutting fluid system only, because the narrow holes that are made on the tool as well as workpiece has to pass by certain pumping system which you fit externally. Okay, so that is what you want. So methods of application, if you see the multiple nozzle system, normally this is another way of system. So since we have seen 4 systems there, if at all the machining is for long time, and if you are cutting the large structures like aerospace structures or another big structures, there normally you require multiple nozzles to cool your tool. Okay, more than one nozzle may be used for some cutting operation. Okay, so that is what you can see here, a single nozzle system, and you can see a multi nozzle system. Normally depends on your cutter size also. Whenever you are cutting a very big aerostructures like what you are cutting, like plane wings and all those things, there you require tool should not break at middle or something, so you need multi jets. Not only that, whenever you cut for advanced materials, normally you require multi jets. This type of application is used for experimental work when the effect of large number of cutting fluids are being studied and applying the tool. This is the one of the technique. Apart from it, nothing to do. Only thing that multi jets are there. If you have the different types of cutting fluids, you can also try, so that the mixture of cutting fluids will be there. So this is nothing to do with the sentence, but I am just guessing and explaining that if you have a multi tanks and multi pumps where the nozzle is individual entity, then you just pump different types of cutting fluids, and you can get the forces, tribological aspect, surface finish and all those things. That also can be taken up as a research and you can do it. Okay, so some special considerations are there. If at all you are machining certain material, you should not use this type of chemicals. If you are using this type of chemicals, you use in the closed system, don't use in the open system. It will affect and all those things. There are special considerations are there. So machines need to be washed after the fluids have been used. This is a primary requirement, because the cutting fluid viscosities are different to different fluids. If the cutting fluid is falling, if the viscosity is very high, it is very difficult to wash off. So you need regular washing. If at all I have taken my lunch, I have to clean my plate as soon as I complete. So that will be easily cleaned. If you are cleaning after 2 days or 1 day, what will happen? It will be dry. So it will be very difficult to clean. So that's why you should wash as soon as you use it. Use the cutting fluids may undergo chemical changes. So when the cutting fluids normally are mineral oil based, which are chemical compounds or carbon compounds, alkene, alkyne, as I said, whenever this fall in the high temperature region, what will happen? There is a chemical cracking takes place. Chemical cracking takes place and its originality will be loose. Its cooling property, lubrication property will be disrupted. Okay, because it changes its chemical structure. Okay, settling and skimming, centrifuging and filtering help to avoid these bad effects. Okay, filtering, if you can filter it, if assume that whenever the first machining is going on, what is happening is particles in the machining particles will also come in contact with the cutting fluid, and it will also have a chemical reaction to it. That's why you will always should have some filtering, and you can even use the centrifuging to separate it out. Okay, the cutting fluid containing sulfur should not be used for nickel based alloys. Okay, this is the one of the indications or precautionary indications that normally the cutting fluid suppliers will always do. If at all I want to do the for nickel based alloys, they will give certain different cutting fluid. Chlorine should not be used for the titanium. because these are chemically affinity will be there for these two applications. That's why normally it is preferred to not use the chlorine with respect to titanium. Okay, situation in which the cutting fluids are harmful normally are interrupted cuttings. Okay, in an interrupted cutting, basically the thermal shocks will be there, mechanical shocks will be there. So the cutting fluid may not act properly because the cutting fluid will have sudden quenching effect on the cutting tool, but the sudden shocks or sudden thermal shocks will have different temperature will increase. So increase and decrease of temperature will be instantaneous. So that is one of the reasons. Apart from this, there are some other reasons, some other textbooks also will give. So interrupted cuttings, normally you have to use some other cutting fluids, may cause the chip curlier, thus the concentration and the stresses closer to the tool tip. Okay, sometimes it will cause this. If the situation is like, assume that the chip is curling there itself, your nozzle direction or your sending direction should not assist the existing one. That is what. Okay, concentrate heat closer to the tip, which reduces the tool life. Okay, so what I mean to say is, in the 2 points, the basically the situation you should not bring if the thermal shock is there or the mechanical shock is there. On top of it, you are again impinging with a very high velocity. Okay, it will have an erosion effect. The another situation is, if my chip is curling there itself, if you are assisting by putting in a wrong direction of your cutting fluid, it is not good. Okay, you put such a way that it will lift off and it will send out. Okay, that is most important. Now we will look into the properties. What are the properties that I am looking? It should possess good lubricating properties to reduce the friction, which we have seen. Non-corrosiveness, that is rust inhibitors are inbuilt, should be made whenever the suppliers of this cutting fluid supplies, and natural, so that not react chemically. So it should be as natural as possible. Why I am telling you this? Some of the papers, if you see, people are using coconut oil, people are using castor oil, people are using palm oil. Palm oil based cutting fluid papers you can see in Thailand based, Malaysia based. Many people are working in this area. So Jetrofoil, these are the oils that people are working. So why don't many people are in India also working. So you go through the literature and find the combination of these oils, or combination of these oils along with the water, or can be mixed with mineral oil, because mineral oil has a better lubricity. If the cooling ability of this one is better, then why don't we mix along with the water? So only thing is that you should choose for right emulsifiers which can do, so that most of the cutting fluid will have natural tendency, so that the chemical aspects will go down. For example, whenever you want to purchase a soap, whenever you want to take the bath and whenever you want to purchase a soap, the first thing a person who knows some of knowledge about the soap is just he rotates this at the back side and check what is the TFM of this one. Okay, why they will check? Normally TFM stands for total fat material or total content of the fat, which is non-chemical. For example, if you take I am just not advertising for anything, just let me take the advertisement of the government of India, where many people may not like the animal fat in it. So the best way is going for, assume that Mysore sandal soap is there. So normally total fat material, the fat material that they are taking, most of the material that they are taking is sandalwood oil. So oils is nothing but the fats. So if oil content which is coming from the sandalwood, if it is putting on my skin, that is good for me, rather than the chemicals made soaps. Okay, so sorry that my wish is not to advertise or something, just I am taking for example, because if you have less chemicals and if you have more fats which are natural fats that are coming from the plant, which is good for your health, that is very good. So choose a soap, not only that what I specified, where the total fat material is more, which will help you. If at all the fat is coming from the plants, that is still more better, because it is a natural, biodegradable, everything will be there. Okay, that's why this point is completely valid, where you should have a natural content, so that the chemical reactions should be very less on the machining surface or the operator health, or it should not emit any chemicals or something. It should not very easily flammable. That means the machining conditions will go around 300 to 1000 degrees, depend on workpiece and tool combination. Okay, on this tool combination, normally the temperature will be slightly increases. In that circumstances, what will happen? There may be a chance of flammability. So your cutting fluid always should avoid all these flaming things. It should not catch fire and all those things. So it should be vice versa. It should drop, or it should avoid the firing. That is one of the property. So it should be stable whenever you use, and you can store it. Okay, it should be completely stable. It should not age with respect to the time. Okay, any fluid will have certain age, or afterwards expiry date will be there. So the expiry date should not be very low. That is what the statement says. It should high heat conducting. If it can, heat conducting ability of this one will be very high. If it falls between my cutting tool and chip, if it fall here, what will happen? It will conduct away most of the heat. That is what everybody want. Conductivity of the fluid will be very high. That will take away the heat. Okay, the harmless to the skin of the operator, because whenever the workpiece, assume that still we have studied only the turning process. So workpiece is rotating with a very high speed. If my cutting fluid is falling, what will happen? There may be a chance of splashing. It may splash on the hands, it may splash on the face, it may splash on the head, depend on the operator's position. If he is like this, it may splash on this one. So many things are there. So even though it splashes on his face, you should not harm the operator. Low priced to the minimum production cost. That means that the production cost of this one will be less, so that you can procure it at economic price. Okay, these are all the requirements, the properties a consumer looks at whenever he want to purchase these things. Okay, how to choose the choice cutting fluids? Which type of cutting fluid I want? This type of cutting fluid I don't want. This type of cutting fluid I want, and all those things. How do you choose? You will choose based on which basis the cutting fluid is selected. Just it is a question. So what is the basis for it? Type of operation, whether I am going for turning operation, whether I am going for the broaching operation, whether I am going for the knurling operation. This is one criteria. The second criteria is the rate of material removal, whether I want to remove a bulk, whether I want to remove a minimal, this type of thing. Whether if I want to go and remove a huge amount of material, then I have to choose according to it. If my material removal rate is very fast, heat temperature will be very high. So I have to use coolant based cutting fluid. My conditions are slowly removed, but large time is a huge time. So you go for a lubricant based. So the material of the workpiece, if the material of the workpiece is very hot, so the temperature generation is very hot. So you have to use both the things, because it also try to upgrade the tool. So you have to choose optimally. At the same time, material of the tool, normally people talk about the combination and hardness ratio. Normally tool hardness to the workpiece hardness should be slightly higher. If it is higher, normally 3 times, 5 times, if it is 7 times, that will be better. Okay, so depend on this combination, normally you will choose the cutting fluid also. Okay, surface finish requirement. If the surface finish on my product is required, then I have to obviously choose lubricant dominated, because the lubricant is helps the abrasion between my flank surface and the my final product. Okay, cost of the cutting fluid. Obviously, whenever we go to the shop, you just see what first you like the shirt, 3 4 shirts, and you see the cost, and you whatever is sits in your budget you will purchase. So even though the cutting fluid is very good, if the cost is too high, the production cost will go up, in the product cost will go up. So obviously you choose the effective cost of the cutting fluid. Selection of the cutting fluid, how do you do? The workpiece materials and machine tools, biological considerations. You see the biological considerations like whether it is fastly degradable or whether it is bacterial will formation is very fast or something, you just see. And the environmental aspect, machine tool operator is close proximity to the cutting fluid, thus the health effects is a primary concern. Okay, so you choose one appeal for the people who are from the industries. You should not only look at the profits. I'm just it is my intent, it is not my intention, just I am casually telling. So you should also look at the safety of the operator or the whose staff is working. We should provide him the basic necessities to, like mask, proper apron, gloves and all those things, so that the splashing won't take place. At the same time, fumes that are coming should not go into the operator's noses and cause us lot of problems. Okay, these problems I will discuss in the upcoming classes. Progress has been made to ensure the safe in use of the cutting fluid. So safety, what are the safety precautions whenever you are using the cutting fluid? You have to, one has to ensure whenever you are selecting a certain cutting fluid, recycling involve the treatment of the fluid with various additives, agents, biocide, deodorized and water treatment. Okay, you should be able to involve in the treatment of this fluid where a lot of additives are there. You should be, what the bottom line of the story is, you should select a good cutting fluid which gives the mechanical performance in a better way, as well as it should not be harmful for the human who is near to that one. That is what the intention is. Okay, so the benefits of cutting fluids in the machining, it will improve the tool life, lowers the forces, obviously after seeing all these things, improves the surface finish because the lubricating characteristics will help, and finished surfaces are protected from the corrosion because the rust inhibitors are the part of this cutting fluid. So the corrosion will be minimum. Okay, so these benefits you will get if at all you use. But the cutting fluid cost, if you see the current market where we procure the normally servo based cutting fluids is 20 liters is around 2000 plus or minus 500. Normally I am saying 2500 plus or minus 500. So it may range between 2000 to 3000 rupees. So but 20 liters, each liter if you mix with 10 liters of water, so it is economic. But the only thing is that you have to look from the corrosion point of view because the water content is more. At the same time, you have to see whether the harmful chemicals are emitting whenever this cutting fluid is falling in the machining region. Okay. So anyhow, this will give you good mechanical properties, like I am not saying mechanical properties, sorry, that surface finish and forces will be anyhow, it will be reducing, but you can see on the other side of the coin like ecological aspects. Okay. Now the cutting fluids depending on the type of machining operation is need to may vary, which is cooling or lubricant. It is same thing that and the effectiveness of the cutting fluid depend on the number of factors such as type of machining operation and all those things. I said in the graph also water is an excellent coolant, and cutting fluid depend on the severity of particular machining operation. If it is a turning operation, it is not much severe, but if it is a broaching operation and all those things, it is a high pressure things where you need proper lubrication and cooling. So for that purpose, you have to use a special type of cutting fluids where you will have high pressure additives and all those things. Cutting fluid action, normally how the action takes place in terms of heat extraction or the lubricating. So normally this is a capillary action, just may highlight first before reading this. Cutting fluid seeps from the sides of the chip through the capillary action of the interlocking network of surface asperities at the interface. That means whenever you are sending a cutting fluid, basically it will go from higher concentration to lower concentration by the capillary action. Just it will go and unlock the interlocking network between chip and tool. So that is the action. Discontinuous cutting operations have more straightforward mechanisms for the lubrication application, but tools are more susceptible for thermal shocks. Okay, what I mean to say, whatever the above point, this point holds good for continuous chips. If we are going for discontinuous chips, it is straightforward because chip are not entangling there. It will becoming a powder form or a small fragments. So the proper lubrication or cooling will be done in the machining region. However, these nanoparticles or microparticles that are forming is a discrete particles. So discontinuity will be there in the nano range or a micro range, which may cause shocks. Okay, so you have to take care about the cutting fluid, appropriate cutting fluid in this process. Normally, if I am not using the cutting fluid, what will happen? Okay, so just let me take an example which I have taken from some other source. A machining operation is being carried out with a cutting fluid that is an effective lubricant. What will be the changes in the mechanics of the cutting operation if the fluid is shut off? Assume that I am not using the cutting fluid, but I am using the turning. What are the problems that one can experience as the operator? So, chain of events taking place if the cutting fluid is shut off. What are the things? If you see, the friction on the chip tool interface will increase, okay, so which will destroy the tool. The shearing angle will decrease because if the shearing angle decreases, what will happen? Now, lot of problems will come. The temperature in the plastic shearing zone will slightly increase. Okay, if my shearing angle is like this, the line is small. If it goes like this, what will happen? My length will increase. Okay, so if it increases, what will happen? The temperature, the number of atoms in the workpiece material will goes up. Okay, so there is a heat increase problems will be there. The shear strain will increase. Normally, the strain will increase. If the strain increases, temperature increases, the chip will become thicker. As I said, the shearing angle decreases, so chip will become thicker and built-up edge is likely to form. If the built-up edge forms, the surface roughness will deteriorate and the tool wear also improve and other things will take place. Okay, how if you can see from other point, as a result, what are the problems it will be? The shearing energy in the primary zone will increase because I have to put more and more energy. The frictional energy in the secondary zone will increase. If the frictional energy increases, what will happen? Coefficient of friction will increase. So, okay, the total energy will increase. On an average, if the part of energies are increasing, so the total energy that is required will also increase. Okay, the temperature in the cutting zone slightly increases. If the temperature in the cutting zone, obviously you have seen it is increasing. If the increasing thermal softening of the workpiece takes place, if the thermal softening of the workpiece takes place, tool will fail at very faster rate. Okay, surface will deteriorate and the dimensional tolerance. If the temperature of the tool increases, what will happen? This temperature will impart into the machining of the thermal conductivity will go across the flank surface, which is connected to the final product. This temperature will go into the product and the product heating will takes place. If the product heating takes place, what will happen? The tolerances of the product will go. That means the nano dimensions of the product may increase. Okay, so at the same time, it will also destroy the metallurgical surface that is there on the surface. So, metallurgical aspect of the surface also will deteriorate. Okay. So, not only mechanical dimension it will change, it will also change metallurgically. That is what I want to say. Okay, so now we will move to the cutting fluid additives. So in this class we have studied about the machining fluids, which is a major part of this course. So we will talk about these machining fluids in a continuous spectrum of at least 2 weeks. So basic problems why we required to the cutting fluids we have studied. Then what are the proper methods, how to use cutting fluid in the right direction and the right place of machining we have to use, like that we have studied. The cutting fluid functions we have studied, then types of cutting fluid, water based cutting fluids, semi synthetic, mineral oil based, what are the lubricating properties and cooling properties, how we have to take care, and all those things we have studied. We have also studied about the various type like flood cooling, mist cooling, that high pressure cooling, and interconnected cooling and all those things, multi jet cooling for machining of big structures and all those things. Special considerations, normally what we have studied is like sulfur should not be used for nickel applications, and chlorine should not be used for titanium applications and all those things. Some of the special considerations also we have come across, and we just move to the properties like it should have high heat conductivity and other things, so that it will take away most of the heat that is generated during the machining operation and other things. So it should also have price, because price is the most important thing whenever you decide or whenever you want to purchase a product. 17% of the product cost goes to cutting fluid. Okay, you have to choose the cutting fluid at minimum price, easily accessible cutting fluid at minimum price, so that the price of your cutting fluid cost that is in the product should be less. At the same time, you should go for certain alternatives like mist cooling, so that the cutting fluid volume consumption will be very less. Okay, that should be about the cutting fluid, and it should not be flammable, so it should not catch fire, especially when the machining action is taking place with respect to some of the advanced materials like magnesium alloys and all those things. You should be very careful because the oxidation problem of the magnesium is one of the problems. So people who are interested to do the machining operation of magnesium alloys should be take care about the cutting fluids that are flammable. So you should avoid the firing and all those things. Okay, normally you should choose the choice of cutting fluid normally which are from the point of surface finish requirement, or whether the high material removal requirement, whether your requirement is a high material removal, then you have to go for, whether your requirement is a high speed machining application, the cutting fluid should be cooling type. Whether if you are going for slow type of machining operation, then you have to go for the lubricant type of cutting fluid. And some of the considerations also should be taken from the environment point of view, as it should be chemically inactive, and most of the cutting fluid should be naturally oils, so that if it falls on the operator, and it should not damage his health. Like if it falls on the epidermis of the skin, then it will cause dermatitis and all those things. If it falls on the hair follicles will come. That's just I will explain in upcoming classes. Anyhow, this is, so if you have a coconut oil based cutting fluid, what will happen if it is rotated at very high speed? Even the coconut oil falls, not much action will take place. Okay, so that is about the cutting fluid benefits and how type of thing. We have also seen one of the example where if you are not going to use the cutting fluid, what are the detrimental problems that deteriorate the process, and all those things will be here. So cutting fluids, where we have to use, where you should not use, and all those things like discontinuous cutting, you should be wisely use the cutting fluids and all those things. This is all about today's class, and we will see what are the additives that we are going to use in the cutting fluid in upcoming next class. Okay, thank you.